I think everyone in this room can agree that software applications in general really try to do one of two things. Number one, that they are trying to generate money for your company. Perhaps you have some sort of software as a service, or it is a product of some type that earns your organization money. Or number two, it is a tool for saving your company money, in that it is a software application to reduce inefficiencies in your organization. So, therefore, the conventional wisdom states that reducing the friction that end users experience when they're using your applications will either generate more money for your organization, or it will save additional money for your organization. But measuring the effectiveness of how you can measuring the effectiveness of an application with regards to generating money or saving money is often difficult to figure out. There's a lot of different metrics at play. There may be everything from whether your user experience is good or bad. If you're using too much bandwidth, that might cost your IT infrastructure additional money. If you're using responsive design, there's all sorts of things that can affect how users feel about your application. And while we're not going to talk a lot about that today, we are going to cover the idea of compressing an application so that you're utilizing less resources physically, and that you're reducing the amount of time that it takes your users to get into the application. So I'm going to start by talking about some of the conventional wisdom that we as web developers have really been trained to hear. There's a great quote from a gentleman named James W. Frick that states, "Don't tell me where your priorities are, show me where you spend your money, and I will tell you." And when it comes to building web applications, I think this is a fitting quote, because we often need to think in terms of the business value that our applications bring to our organizations. Because ultimately, it doesn't matter what the application you're building does unless it's meeting one of those two goals, generating money or saving money for your organization. So when we look at how you can optimize the physical resources of an application, there are three pieces of conventional wisdom that I think we're all familiar with. First being that smaller applications utilize less hosting space and they take up less bandwidth. So ultimately that costs your organization less money. Does anybody here like fuzzy math? I love fuzzy math because it allows me to do exercises like this. Many of you probably use Sencha Cmd to have a starting point of your application development. And when you run the Sencha generate app command, at a minimum, you're looking at about 65 megabytes worth of physical resources on the file system. That sounds like a lot, and it is. And while your application doesn't actually use 65 megabytes worth of those resources, a lot of it is framework code that you may not be using. There's Sass, which obviously isn't parsed by the browser. It's reading the actual generated CSS. There could be various pieces of build. There are images. There's all sorts of other resources involved here. But what I like about fuzzy math in this context is that if we look at a really large enterprise application, 65 megabytes worth of physical resources may not actually be inaccurate. It's not all JavaScript, it's not all CSS, but you're going to have images, you're going to have other resources that get loaded. So again, in an enterprise setting, you may expect to have 1,000 unique users of that application on any given month. So fuzzy math, 1,000 times 65 megabytes equates to about 65 gigabytes, roughly, of bandwidth that you might need for that application. That's a big application in a big organization. And if you look at a hosting service like Windows Azure, 65 gigabytes of bandwidth will cost you about $63 a month. So we're going to put a dollar number on how much it costs to physically operate an application. So that was the first piece of conventional wisdom, that by minimizing the amount of physical resources, you can save money because you're not utilizing as much bandwidth or as much hosting space. The second piece of conventional wisdom is that smaller applications load more quickly. So when applications load quickly, you're going to alleviate issues with worker productivity or users abandoning the application. There have been many studies that shown that users of a web page will abandon it after 4 seconds of inactivity, or if the page hasn't loaded in 4 seconds. You lose about 25% of your users. Amazon.com calculated that if they slowed down their servers by, what was my number here, or just 1 second, they will lose $1.6 billion in a year. Maybe your organization isn't Amazon, but again, we're putting this in very real situations. Google calculated that by slowing down their web searches by just 0.4 of a second, they will get 8 million fewer searches on their search engine today. And guess how Google makes money? When you click on all those nice ads at the top of the search results. So clearly, you want applications that run fast because it will either prevent people from not using your app or from not generating more money. And finally, smaller applications will work better on mobile devices. And it has a lot to do with the first point, that the smaller they are, the less resources you need, and smaller devices aren't as high-powered as a desktop. So you want a smaller application. The moral of the story here, and I apologize for this being an extended slide, is that we as developers need to spend time worrying about optimizations, even in organizations that are not the same thing as Amazon or Google. So thankfully, there's a lot of really good information available on the web to do or to help you reduce the size of your applications. And back in 2006, Yahoo had what they called their exceptional performance team. They came out with, I think it's 32 or 34 individual performance metrics that you should consider when trying to increase the speed of a web page. And that grew into a tool called YSlow, which is a browser plugin. You can also run it from the command line. There's various mechanisms for using YSlow. It's still very useful today. So I'd encourage you to go to developer.yahoo.com/performance, and you can read all of this that's out there. In fact, that information is so rock solid, I'm not even going to talk about it today because there's really nothing else I can add. Sencha Cmd utilizes a lot of that under the hood to help compress your applications without you having to do anything. So we're going to combine your JavaScript files so that you can minify the number of physical resources. We're going to implement caching in a production environment so that you're not downloading resources again and again as users are visiting pages of your application. And additionally, a variety of other mechanisms to reduce the number of HTTP requests. So while it's all fine and good that advice exists, and it's great that you can go out and read about it, very often we as developers want to have tools that we can point at our application or our web page and get immediate feedback. So I already mentioned YSlow. Chrome Developer Tools has many pieces of this advice built into its Audits tab. And if you came to my session earlier, I sort of alluded to this, that the Audits tab is not well documented, but when you run it against your web page, it will tell you you're not gzipping things as they come off the server, or you need to move your scripts to the bottom of the body so that they load after all of the content has loaded. There's an awesome extension of Chrome Developer Tools called PageSpeed, which takes that advice a few steps further. So you can download that off the Chrome Web Store. It's free. And the page speed API does a series of really interesting things. And out of that grew a node package called TMI, which stands for too many images. And what's great about both page speed and the TMI package is that it will identify situations where you have images on your application which are not well optimized. These aren't necessarily code, but if you're used to sitting in Photoshop, when you export a JPEG or a PNG, may bloat the output of that image with a bunch of metadata that has no effect on the quality of the image. The page speed extension, as well as the TMI package, will tell you which images are not well optimized and even give you a link to download an optimized version. So again, you're just slicing off bits that don't affect the quality of an image that can drastically reduce the bandwidth and the physical resources your application consumes. So I'm assuming that many of you are already familiar with that advice from Yahoo, or that you can play with the Chrome extension on your own time. What I'd like to do would be to spend a lot more of the presentation today discussing what Sencha Cmd can do to help you optimize the JavaScript and CSS for your applications. So how many of you are using Sencha Cmd? Most of you. OK, that's great. I'm willing to bet many of you don't realize the vast number of configuration options that Cmd allows you to tweak in order to do things like further compress your applications. For example, Sencha Cmd defaults to using YUI Compressor as its JavaScript compression tool, but you have the option of using Google Closure or UglifyJS. And as you're going to see in a few minutes, there's no clear-cut answer as to which one you should use. It's going to involve some testing on your part, but we're going to dive into a real-world example. So let's talk about how JavaScript compression works at a high level before we dive into the nitty-gritty pieces. There are some very complicated mechanics involved in compressing JavaScript. The process itself sounds rather simple, where on the left you have some arbitrary JavaScript code. This may be a single class, or this may be your entire Sencha application. And via a compression tool, you do what's called tokenizing your code into an abstract syntax tree. So it actually visualizes, in a sense, the possible code pathways and the various properties and variables and values into this abstract syntax tree, and then recompiles that tree while minifying things in that process. So after you've tokenized what your code looks like, the parser will say, well, I can squeeze a variable name down to a single character, and I'll just manage all of the references to that within the scope of your code. So it sounds relatively simple at a high level, but we're not going to dive into the actual mechanics and the algorithms involved, because that's really outside the scope of my expertise. And I think we've got more interesting things to talk about in terms of what the results are. I mentioned Sencha Cmd has 3 different options for compressing your applications. The first is YUI Compressor, which is the default option for Sencha Cmd. It's a command line utility written in Java, and it performs both JavaScript and CSS compression, which makes it ideal for using that tool in most projects, because it does both JavaScript and CSS. Google Closure compiler is also built with Java, but it only does JavaScript compression. So it does not compress any CSS code. It has additional flags to help customize the way in which it compresses your code. And Closure has other options, or it has other mechanisms to hook into the compression process. So you can use it from the command line, but they have a public API. You can fire code up to the API and it returns down your compressed code if there was some reason that you needed to do that. So it's a pretty cool tool, but it does not do CSS compression. What's interesting is that UglifyJS is the only one of these three tools physically written in JavaScript. It also only does JavaScript compression. It does not handle CSS compression, but it does allow you to highly configure the way in which it compresses your code. So to summarize this, YUI Compressor is the only one of these tools that does both JavaScript and CSS compression. YUI Compressor and Closure are both written in Java, which is important because Sencha Cmd is written in Java. UglifyJS is similar to Google Closure in that it's highly configurable, and that it only does JavaScript compression. But because it's written in JavaScript, Sencha Cmd has to run it through the Rhino parser. And that has other implications we're going to come back to here in just a moment. The easiest way for me to illustrate all of this to you is by generating a demo application using Sencha Cmd and then to load it into a browser and start to show you what happens as you're compressing the application with these different options. So I'm going to jump into Firefox. And what I have is an application I generated using Sencha Generate App. You can see I have not customized this in any way. It is exactly as it appears after running that through Sencha Cmd. And the reason I chose Firefox for this experiment is that they give us a nice little graph when we load the network. So if I click on the thing at the bottom, it'll tell me in a nice little pie chart most of the time spent loading application resources is loading JavaScript files. So 22 of the 25 total requests are JavaScript. This is not surprising because the app is running in development mode and we're using the ext loader. But you can see we've got 22 JavaScript files. The total weight of this application is 1.6 megabytes. It took 0.16 seconds to load, which, all things considered, isn't that bad for 1.6 megs worth of code, and that nothing was cached. So that's what we get out of the box there. What I would like to do would be to show you what happens after we run Sencha app build. So I've already done that. Let me host the production build. And after we've run this, remember, so by default it's using YUI Compressor. We can now see that rather than 25 total requests, we have 4. And while JavaScript is still the vast majority of that in terms of total weight, we only have 1 JavaScript file instead of 22. The total size of the application dropped from 1.6 megabytes to 1.4. And the time it took to load dropped from 0.16 to 0.02. So although this is not an application you're ever going to use in production, because clearly there's nothing to it, you understand how this scales out to whatever applications all of you are building. So there's more than a tenfold decrease in the time the application took to load. A considerable number of HTTP requests have been eliminated, and the total weight of the application has dropped. So clearly using a JavaScript compression tool is a good idea. But it's possible that by tweaking how Sencha Cmd minimizes your application resources, you can squeeze a ton of extra performance out of your application. If you look at your app.json file when you do Sencha generate app, you're going to see this empty object called production, in which you can add a variety of different properties to tweak how your production build is run. And one of the things you can do is add a compressor that defines whether you want to use YUI or Closure or UglifyJS. And when you then run Sencha app build after modifying this, it will automatically swap out the compressor for you. Now, what's really interesting, and I don't know if I can zoom in on that chart. I should have made that bigger, but what I've done is to graph what the total size of the demo application is after using various compression techniques. So at the very top of that table, you'll see the total size of an application. This is not the demo application I just showed you. This is a separate app where it was somewhere in the range of 5.1 megabytes worth of application resources. Running it through YUI Compressor, I can squeeze it down to something like 21% of its original size. Using Google Closure, got a little bit smaller. Or running UglifyJS was the winner in this case at whatever that says over there, 20.6% of its original size. So that's really interesting. And clearly, the message here is we should all be using UglifyJS. Except that's not true, because we're not taking into account how a web server may gzip the resources that come down from your server. And when you run the build through gzipping, what's interesting is that even though UglifyJS in its raw JavaScript size was the smallest compression through Sencha Cmd, when you pass it through gzipping, the result was bigger than after you compressed the Google Closure, or sorry, after you gzipped the compressed output through Google Closure. The moral of the story here is that you really need to play with all of the settings and see how your application is going to react. There are other considerations you need to make, where one of the many reasons we default to YUI Compressor in Sencha Cmd is that it's really fast. And this was run on my old MacBook Pro. That YUI Compressor took about 30 seconds to run a build. So your experience may vary based on your machine. Google Closure took about twice as long to run. That's, at about a minute, maybe that's acceptable. It's not ideal, but for additional compression, maybe that's worth it. UglifyJS takes about 31 times longer to run. And that's because we have to throw it through Rhino, because it's written in JavaScript. So what you may want to consider as you're building your applications out in the wild, if you're going to run production builds on your local machine several times a day, it may be worth your while to use either YUI Compressor by default or Google Closure, because you're running them very frequently. And as long as the output size isn't very dramatic, maybe a couple of kilobytes isn't something to stress out about. If you're going to run your application on a or if you're going to build the application on a build server, it may be worth your while to squeeze the extra couple of bytes out of compression by using whatever tool gives you the best compression, which may in fact be Uglify. So that's definitely something to take into consideration. How can we further customize how Sencha Cmd works with the build process? So inside of your compressor block, which I showed you a moment ago, you can actually, for only Google Closure right now. You can add additional compilation flags inside of this compressor object. We will be supporting UglifyJS hopefully sometime soon. Nobody's been screaming for it, so we haven't rushed that. But as an example, let me jump into my IDE. And I'm in my app.json file. And I told you there's a production object inside of which I added a compressor. And even though by default this isn't here, I stuck with YUI. But if I wanted to, I can now uncomment these lines. And it will now use Google Closure to run my production build. Any other keys that I pass inside this object are taken by command and passed to the Google Closure command line API. And these are documented in the Google Closure API. I don't know that these two properties actually do anything. But if I run Sencha app build, we'll let this go for a moment. And then I move back into my production build. And reload the app in Firefox. So literally without changing anything, we've now dropped another maybe 50 kilobytes off of the production build. And that's literally without having done a single thing except swap out the compressor. So imagine what this will do on a considerably larger application. Oops. So that's all been in the JavaScript arena. Sencha Cmd also is fully integrated with our Sass themes. And so we can talk about how you can further compress your CSS resources, because clearly a lot of downloading a rather large CSS file, if you can reduce the size of that resource, not only will speed up the loading of that particular file, you are eliminating lots of CSS selection rules the browser doesn't have to parse and keep in mind. So your runtime performance will actually be faster. Whether or not you notice it is debatable, but you are asking the browser to do less work. So by default, the Sencha theme that's generated when I look at this demo application is about 248 kilobytes. Whenever I wrote my slide, it showed up as 291, but it's a rather sizable chunk of CSS. And you can look in the XJS or the Sencha Touch documentation at your global CSS, and it will tell you what all of the global CSS rules are in your theme. And I decided it would be interesting to play around with some settings just to see how small I can make an application. If you're lucky enough to not have to care about IE 8 and 9, you can turn off the include IE flag, which saves you a whopping 143 kilobytes worth of CSS. That is roughly half of the CSS the framework gives you, which is pretty cool. So is there anybody lucky enough to have that? As a few of you, fantastic. So go do that. There are other really cool things you can do which get slightly more advanced and can cause some problems if you're not careful. So if you turn off the include default UIs flag, you can save another 122 kilobytes worth of CSS. So that's a grand total of 265 kilobytes of 284. The caveat to turning off all the default UIs is that none of your widgets will have any styling. So that may be a problem, but the reason I mention this is that every widget in the framework, whether it be a panel or a grid or a header, a toolbar, a button, they all ship with multiple UIs. There's often a light UI versus a dark UI, various other flavors depending on the widget. They all default to the option that is include default UIs. So you could either turn them all off and then just include the ones you use, or you could do the opposite and leave it on and turn off the ones you don't use. The pathway I would recommend would depend on how big your application is, because if you're using most of the framework, you probably don't want to turn this off. You would want to turn off just the ones you don't use. But you can save lots of CSS in this case. There's another thing many SaaS developers don't think about, which is how you actually write your SaaS files. The convention, as far as I've seen inside the Sencha themes, is to nest the SaaS declarations inside of one another, so that on the left we have a foo class inside of which we're defining bar, inside of which we're defining baz, so that the baz class inherits things defined inside of bar, which also inherits anything that's defined inside of foo, because that's very convenient. But it also bloats your CSS because, as we'll see in a moment, the way it outputs your CSS selectors is very verbose, as opposed to being more declarative in how you write your SaaS. You could say, I only care about, foo bar, meaning that if it's a bar inside of a foo container, that it has these specific styles. And then baz, we don't really care if baz inherits anything, so we're just going to leave that on its own. And just the code you see here on the screen, there is a whopping 9 bytes worth of difference, which I know you're like, yes, 9 bytes. But let me show you what the output of that CSS physically looks like. So I'll show you the nested context first. So this is exactly what I had on my slide before. And when I look at the nested CSS, you'll see that we see foobar and then foobar baz. So in the case of the baz class, I'm suggesting maybe you don't care if we're only doing baz inside of these two. It completely depends on how you write your CSS and how you use your CSS. But it's something to think about, because when we look at the non-nested and then view its output's roughly exactly the same as what the SaaS looked like. And so the whopping 9 bytes came from not including the foobar parent selectors in this case. So I would encourage you to play around with how you're writing your themes so that you could hopefully squeeze out some additional performance. And as I said, asking the browser to do less work by giving it fewer selectors to parse, you may see a noticeable difference in application performance. It completely depends on what you're doing and how many things are on the screen, but it's not unlikely that you would see performance improve there. So I figured if I haven't bored everyone to tears, I'd leave lots of time for Q&A. So please come on up to the microphone if you have any questions. Is this thing on? No questions, really? OK. Feel free to grab me afterwards if there's something specific to your use case that you're curious about. But thank you very much for attending. And I look forward to seeing you guys out here afterwards.